Okay, this video is all about calculating the heat of neutralization, or the enthalpy of neutralization. The enthalpy of neutralization, that's the change in enthalpy that occurs in a neutralization reaction, and it's calculated per mole of water that is produced. Okay, so on the screen you've got an example of a problem where we're going to be calculating the enthalpy of neutralization for a chemical reaction. Now, first of all, you'll note that we haven't actually been given the concentration of the sodium hydroxide, so we're going to assume that the sodium hydroxide is in excess and that it is the number of moles of ethanoic acid that is a limiting reagent. Okay, first step, we're going to write an equation. Okay, so we have sodium hydroxide reacting with ethanoic acid to produce sodium ethanoate and water. And this equation is actually balanced, so everything is in a 1-to-1 ratio. Okay, first step is to work out the number of moles of the limiting reagent, which in this case is ethanoic acid. I'm going to use the equation N is C times V. Okay, the concentration is 2 moles per litre. The volume is 50 millilitres, which is the same as 0.05 litres. And when I multiply these two numbers, I end up with 0.1 moles of ethanoic acid. Okay, so I've got 0.10 moles of ethanoic acid. Okay, the next step is to work out Q. Now, Q, you might remember from the year 11 course, is MC delta T. That's where we work out the amount of heat that is released or absorbed by multiplying the mass of the substance that is being heated or cooled times the specific heat for that substance times the change in temperature. Okay, now in this case we're combining an acid and a base. They're both in solution, so they're basically water. Okay, so a solution of acid or a solution of base is mainly water. Okay, so the substance that is being heated or cooled, that's the water. Okay, we're combining 50 milliliters of the sodium hydroxide with 50 milliliters of the ethanoic acid. So that's a combined volume of 100 milliliters. So we've got 100 milliliters of water that is being heated. And 1 milliliter of water weighs 1 gram, so that's actually 100 grams of water that is being heated. So the mass of the substance that's being heated, that's 100 grams, or 0.1 kilos. The specific heat of water is 4.18 times 10 to the power of 3. Now that's the value that you read from your data sheet. And then the change in temperature, we've got, in the question it tells us that the temperature started at 22 and ended up at 33.7. So we're doing 33.7 minus 22. Okay, when we put this into a calculator, we end up with a value of 4.89 times 10 to the power of 3 joules, which is the same as 4.89 kilojoules. Okay, that's the amount of heat that is released, but that's not per mole of water yet. Okay, now we need to go back to our equation, and in our equation what we can see is that for each mole of ethanoic acid we get 1 mole of water. So the ratio of ethanoic acid to water is 1-to-1. Therefore, the number of moles of water is the same as the number of mole of ethanoic acid, so it's also 0.10. Okay, the last step is to work out the enthalpy of neutralization. We're going to have to divide Q by the number of moles of water. The other thing to think about as well is that the enthalpy of neutralization, that's the heat change, and in this case heat is being released. So we're going to have to change the sign for Q. Since the heat is released, Q is actually negative. Okay, so the enthalpy of neutralization, that's Q divided by the number of moles of H2O. So Q is minus 4.89. Okay, so minus because heat is released. divided by the number of moles of water we just worked out to be 0.10 moles. That gives us a value of minus 48.9 kilojoules per mole of water. If we go back to the question now, though, what we can see is that in the question, some of the values are given to us to 3 significant figures, and one of the values is given to us to 2 significant figures. So I need to give my final answer to 2 significant figures. So my final answer is minus 49 kilojoules per mole to 2 sig figs. Okay, so that's the heat. That's how to calculate the heat of neutralization. Okay, the next thing you're going to have to do is to use an interactivity to get some practice at this type of calculation. Okay, it looks like this. Okay, so if you have a look at the table, what I've asked you to do is to test out different combinations of solutions and to determine the heat of neutralization and to see if you can find a pattern in the data. So for example, for the first one, you've been asked to combine 100 milliliters of hydrochloric acid. So the first solution is going to be hydrochloric acid, and you are placing 100 milliliters in there. The concentration that I've asked you to select is 2 moles per liter, and the other solution that we are selecting is sodium hydroxide. Again, 100 milliliters and 2 moles per liter. Okay, so we'll go to the next step. You're now ready to start the experiment, and you'll note that the temperature is initially 20 degrees for both reagents. Then when we start the experiment, okay, you can see that the final temperature is 33.62 degrees. Okay, and also looking at the graph, you can see that the temperature initially rises and starts to plateau out. So if we were doing this in class with the data loggers, you'd be looking for the graph flattening out, and that would tell you that the reaction has completed. Okay, so that's the data that you need to carry out the calculations. So you've got this table here to fill in. Okay. You're going to be testing out all of these different combinations and completing the table, and then there are some questions for you to have a go at answering underneath the table. When we have our Zoom session, we'll talk about some of the answers to those questions and what you found out by doing this experiment. Okay. There are also some more heat of neutralization questions for you to try out on page 2 of your OneNote.